Welcome, everyone. Thank you for joining us today. My name is Kim Davis, and I manage programming here at the Accelerator, stepping in for Zach Semke today. Just want to take a quick moment to thank you all for joining us and for being here. We really look forward to this presentation by Timothy Locke. I will hand off to our co-hosts. Today we have Zoe Kaufman and Carmel Pratt joining us. So Zoe, take it away.
Yeah, welcome everybody. Happy to see you at Passive House Accelerator live next up, pre-Thanksgiving episode. And I just want to say that I am very grateful for this community and also for the Reimagine Buildings Collective, where we can really act as a community and share what we're doing as generous people who are doing very forward-thinking things and trailblazing. Speaking of which, Carmel, would you like to introduce our guest?
I would be grateful to. In the spirit of gratitude, thanks so much to Timothy Locke for joining us today. Timothy's a management partner and specializes in the management and direction of large-scale institutional projects and spearheads OPAL's practice's overall approach to building ecology and climate action. He firmly believes in the importance of architectural design in producing transformational, ecological, and positive societal outcomes, and is committed to maintaining the highest quality of process and integrity of ecological architectural design, practice, and implementation. He comes to us from Syracuse University, where he got his professional architecture degree. And prior to relocating to Maine, he practiced extensively in New York City with several firms on a wide range of building scales. Tim also sits on the Maine AIA Board of Directors, the AIA National Strategic Council, and is the co-chair of the Maine AIA Committee on the Environment. Timothy, thank you so much for joining us, and the floor is yours.
So thank you so much for inviting me to share with you all today. I'm going to talk a little bit about how we're approaching overall building ecology at our practice OPAL in Belfast, Maine right now. And just specifically through the lens of material choice and low carbon design. I'll be pretty loose about how I define materials in this talk, but we'll get into it. I actually grew up in Maine. This is me on the top of Cadillac Mountain when I was 4 years old. And this was so 40 years ago today, almost today. It was a couple months earlier than this, in August of 1984. And, you know, I like to talk to our staff when they have reviews every year and always ask them a question about, you know, where do you see your career going, like what excites you about design, excites you about sustainability. And I think you start to see people kind of grow and change over time. And at the beginning of people's career, I think almost all of them are like, someday I'd really like to be able to design a house, like just soup to nuts. I could do the whole thing myself. That's a great goal. And I was thinking about this the other day, like what is the driving force and thrust behind my career now? And I think for me, I just dream of having a true zero carbon building within my lifetime. I want to see it happen. Maybe it'll be me, maybe it'll be somebody else. But to me, that's all centered around how we approach, how we measure, how we approach how those measurements help support our design choices. And so always being curious about how we're evaluating our building is really important to me. And that really relates to just a recognition in our practice that the buildings we make are essentially part of our ecosystem. They can't be extricated from our ecosystem. And because of that, that responsibility and opportunity is quite significant. You know, we're not harvesting things from other planets. We can only use what we have here, at least for now. And so that recognition, I think, does help as a motivator in making climate positive choices. And for a long time in our practice, that was driven kind of purely around thinking about PHBP specifically as a design tool. Yes, it's an evaluation tool too, But, this sits next to my desk, not because we certify every project, but because I always want to be able to have a touch point to why we make the design choices we do. For me, those mental models and how we construct our approach to the design is far more critical in a positive outcome than the absolute metrics and spreadsheets, et cetera. So this is a design document, and a methodology is something that was always core to our practice. And then lately we realized, and some of you may have seen this in other speaking engagements that I've had, that had to expand beyond just energy use in the building. It had to be a kind of ethos that we took to many different criteria. And so we created this internal framework that we call the dimensions for building ecology. And that was really just focusing and sorting multiple sustainability criteria and ecology criteria across 5 categories. And the goal for this was to kind of create passive house level benchmarks, put it in quotes, passive house level benchmarks across non-energy related criteria. Like, how could we take the same ethos of first conserving and using less stuff to other categories, right? It was really important that was part of the mission. It also became a really great tool because, and this was kind of like an insight that we'd had, that we saw a lot of clients that were coming into the sustainable design space from other criteria than just, I want my energy bills to be lower. That was sufficient when we were only doing residential buildings. But as we did buildings that were bigger, more commercial, more public, more institutional, people's way-ins started to diversify a lot. And a lot of people were coming in through well-being and healthy community, and not necessarily from, can I have my emissions be as low as possible? That was too abstract. So we created these kind of loose criteria. They were always undergirded with numbers and metrics inside our office, but not outwardly, for each of these. And I'm not going to focus on these intensely, but generally, Habitable Planet was about what we talk about a lot in passive house spaces. It's about mitigating climate change through emissions reduction. That's where all that goes. Circularity was about, how can we be sensible about the stuff we already have, reuse it, and design for a future where our designs are the stuff we'll already have, and being conscious of that kind of time cycle, both forward and back. And you start to see, you can see these little icons on here. It was even interesting to us as we developed these criteria and developed metrics for them, that they started to become very intersectional, like these different buckets of assessment were supporting each other. And of course, we know that a little bit from passive house just through the attention paid to ventilation and how beneficial that is, both from an energy standpoint, but also from an occupant health standpoint, right? And that was like the kernel of this, to create some sort of intersectional framework. It extended through to water, being sensible about protecting our water cycle and mitigating potential impacts from the water cycle and into the building. Resilient ecosystems, so thinking more locally about the site around the building, how we can be very careful about our human-only footprint, the same way we're very careful about our human-only energy use, right? Again, starting to create these parallels between different things. And then lastly, and honestly, this is the one that excites, I think, more of our clients than any other, is an attention to the stakeholders we serve. So ultimately, we're, as designers in these projects, we're tasked with creating a reality that is hopefully a positive impact for the stakeholders' lives that are going to use the building. And that's the case with any scale, right? It can be all the way down to residential, all the way up to large public buildings. And for most of them, there's a very low hierarchy of need. It's like, I want a safe, healthy place for my community to go and participate in whatever activity we had in mind. And so developing criteria around here is some of the ones that actually become our single greatest outcomes to our clients in the end, and often are supported by some of the other buckets as well. And we use that to benchmark all of our work. So we have a spreadsheet that we've developed that uses numbers across all those categories based on current best practice, and try to see if we can hit that kind of passive house threshold of 80% impact reduction in any of those categories. And I don't know, I mean, this is really early on and we made it up, but it's a great tool for trying to see if we can kind of progress beyond just our kind of closed systems assessment of passive house as a standalone certification, and expand that kind of idea into other territories. And so we've been doing that for a few years. And what we started to realize is that maybe our biggest challenge on that is around that first category, and how do we kind of holistically look at a habitable planet and reduction of emissions in a world that is changing the way we produce energy, right? So we talk a lot about that 40% of global emissions, and there's a lot of internal debate in the design fields about, is it, you know, 1/3 operation, or sorry, 1/3 embodied, 2/3 operation? Is it 1/5 embodied, 4/5 operations? Is it half and half? Are we projecting towards that goal? I don't really care. Like, if I'm thinking about the damage of emissions from a building, I'm thinking about the 40% in general. And that my ethos now is that, honestly, the debate between embodied emissions and operational emissions, although it might be beneficial to certain portions of our industry, is actually not beneficial to the overall thrust of getting that 40% part of the pie to be smaller, right? We have control as designers, as builders, over that 40%. To me, I see that as an opportunity. And debate about where the split is not as important, I don't feel. And so the thrust of our practice is we need to look very whole life at carbon, because if we don't, we're going to miss opportunities to potentially just use less stuff, right? And if we are focused headlong on this debate between the resources and the materials and the energy we use, that is infighting that doesn't allow us to reduce the 40% as a total. So we, you know, adopt the current methodologies as quickly as we can. We're very involved, me especially, in discussions about how those methodologies apply to practice, and how to make sure that we educate people that are new to methodological approach to whole life carbon assessment, so that they can adopt some of those practices into their practice. And we look at the usual criteria. So a lot of you have probably seen all of this, you know, the usual modules for the scope 3 of our work as designers. So that's the designs we make that get implemented in the world. And we look at it across the usual modules for life cycle assessment, module A through D, material production, all the way through potential for recycling. So today, I'm going to just give you a brief update on where we are at in the way we apply that, and then we'll look quickly at a project case study. So we always start with the standpoint that our models are definitely wrong. Some are useful, but we need to keep adopting them. We need to keep doing them because it allows us to make that information as useful as possible, but with the understanding that they are going to be incorrect, and reality is going to tell us something that will allow us to inform it better. And we follow these rules. So we want to find common units. We want to be mutually exclusive and collectively exhaustive. We don't want to leave things out on purpose. And if we need to make assumptions, because that's the difference between leaving something out or not, that's fine. But we want to be conscious of the assumptions we're making and be clear about that. So that led us to kind of adopting, at least as a framework for now, what we see as the most thorough methodology in whole life carbon analysis in the world, which is what I feel, the RICS standard. So the Royal Institute contracted surveyors in the UK that published this assessment, and then with some edits as recently as July of this year for whole life carbon assessment in the built environment. It's a very thorough document, maybe not quite as long as PHPP, but it's close. It's about 190 pages. And I would suggest to anybody that has questions about any of the different modules that are used to measure carbon, this is a great educational document too. It explains all of them very well. It explains in clear methodological terms where the boundaries are, at least in the way that RICS has established them, which is really helpful. I've found it to be very helpful as a design tool, as helpful as PHPP. And so we have our unit of measure. We usually are measuring in kg CO2 EQ per meter squared these days. I do a lot less with energy numbers and a lot more with carbon numbers now, because energy numbers can be converted into carbon numbers. And so we can get to a common unit that collects everything. It's very helpful. Obviously, it's not helpful with certifying passive houses because we don't use those units in passive house, but working backwards is also fine. And then we have these different terms that we use for assessment. and upfront carbon, embodied carbon, operational carbon, and whole life carbon. We're really going to focus briefly today on whole life carbon. There are these other ways of measuring that are limited systems boundaries, and we found just not as helpful for us to make decisions, and we'll talk about why. So we have our common unit now, and we want to think about how exhaustive we should be, right? So let me just go through some quick different framed mindsets that we've had in the past and our trajectory towards more ecological buildings when thinking about emissions specifically and just sustainability in general. So the best relationship that I can draw here is, again, now we're going to talk about the burgers. We're finally talking about the burgers, and it took a few minutes, but we love a cheeseburger, right? Tasty. We know it's not healthy, right? We can measure the nutrients that go into that and the amount of energy that's in a cheeseburger, and we know that it's probably more energy than we need for most of us, and so it's a bad, maybe an unhealthy choice as a food. And I think when we think of like early sustainability, I'm talking like 30 years ago, I think the strategy was, well, what if I just put way more vegetables in the burger, right? Like, I don't know how to make it more healthy, and I still want to eat it, but I'll put like way more vegetables in it because that's the healthy stuff, right? I'll put in some zero VOC flooring, and maybe there'll be like a wind turbine on top of the building, and it'll be healthy. Well, all you really did is make it something that's less tasty, and it's still not healthy. It's actually more calories because you've added stuff. I think that's a really good important point. When you're thinking about carbon, being additive is almost always worse. And it's a very rare case when you're doing whole life cycle assessment that adding things actually brings a number down. The other option is to take the most unhealthy thing in it and swap it out with something healthy. To me, this is like the thrust of mass timber right now, right? It's like, well, what if I just change all the steel and concrete to wood, right? Like, that'll be good, right? Well, it tastes a little different. It's maybe slightly more healthy, but it's not really getting at the meat of the problem, which is that, bad pun there, that you should probably just be eating less burger, right? That's a 50% reduction. Like, just eat half a burger and it's just as tasty. So I think we want to try to take that same mindset when we think about those modules that we looked at. So if I take the corollary to the basic cheeseburger where we were 30 years ago, we're talking about, when we talked about sustainability, typically we're talking about, are the materials close to the site? Is it easy and efficient to build? Will there be harmful chemicals in the building, and will they be durable, right? These are like the kind of basic things that we talked about. And then Passive House came along, and we added in an energy component. That's B6 in the LCA parlance. And I think for a lot of people, it was like, oh, we did it. That was huge. Like, look at how much energy we've reduced, right? We could entertain this hypermiler mindset that came from really fuel efficient cars, apply it to buildings, super successful. But a lot of people, I think, stopped there, right? And what we're saying is we really need to look beyond that. And so then LCA became a thing. But somehow when life cycle assessments started happening kind of broadly, people stopped doing some of the other stuff, right? It's like, okay, I'm looking at this full life cycle now, but I'm going to start ignoring energy completely because I'm doing this other thing. I'm doing embodied carbon. It's like, well, technically, operational emissions are part of an LCA. Like, you're deciding to ignore them. So that B6 operational energy should also be reported, not ignored. And people were taking kind of like grossly overestimated reductions in things like the recycling category in module D, which is technically outside of the boundary of the life cycle of the building. It's a projection as to something that could happen in the future. It's certainly not mathematically something that we should be taking as a reduction now. And now people are kind of coalescing around this. Sometimes now we also see things like an effort to do upfront carbon storing, right? But when that happens in deference to actually measuring the full life cycle of the building, you'll get other false numbers. And an organization like RICS has gone to lengths to describe why mathematically and from a scientific approach, stored biogenic carbon in the building should not be treated as a negative number in a mathematical equation that leads you to a total. So when they do upfront carbon, the methodological approach is described quite clearly, that you can show the amount of solid carbon you're storing in a building as a separate negative number, but it shouldn't be reported in the same addition if you're only reporting upfront carbon, right? So you're making a decision in that case to do half an equation. So if you're going to do half an equation, you can't get credit for the part that's going to get re-released down the road when the building decomposes. So some kind of critical things here. So for us in the office, we're really only ever looking at the full life cycle module, and we're very exhaustive in how we get there. And we're also not reporting module D, that recycling component, as part of the total, because it is outside of that system boundary. Again, that comes from the Royal Institute of Contracted Surveyors guidance. We're starting to see more organizations and researchers move in this direction. So RICS, as we've talked about that's the methodology that we follow right now in the office. But ASHRAE 240P is supposed to come out next year, which is going to be following some similar guidelines. ILFI is going to have a new zero carbon certification that is much more whole life based. That's exciting. ECHO project just released in the last month their methodology on harmonizing, and it follows a lot of the same guidelines for whole life assessment that we see in RICS. And then things like the CARE tool, which really emphasize the idea of thinking about buildings as circular and reusable, and decision-making around that related to that harmonization component between energy use and resources. So that allows us to make decisions about being collectively exhaustive. And we need to think then about our assumptions next, right? Because if we're measuring all of this, there's plenty of these categories where we don't yet have enough research or data to model it with an LCA tool. We have to use either guidelines or estimates that are created often by outside groups. So when we're doing WLCA in our office as designers, there are big firms that can do this in a more dynamic way, but when we're doing it in our projects, we have placeholders for certain parts, right? So things like MEP systems, right? How do we measure the impact of those? We have to use an assumption for that. And we're being very careful when we do over energy production that's moving out to the grid. That's technically a different scope, right? It's not part of our system boundary. And so being careful to not use that as an offset all the time. We also want to think a lot about time. We do that in this office too, like that we are following some of the guidance. I'm going to share some stuff that came out in one of AREP's papers from September that was describing time value of carbon and pressure to acknowledge that we have a decarbonizing grid. We know that, and that is falling off. So there is some mathematical appropriateness to valuing the carbon spent now over the carbon that will eventually be spent later, because it will allow for the grid to decarbonize in the meantime. There's also the reality that through radiative forcing that the planet is absorbing carbon as we emit it, not at anywhere near the same rate, but it does have a mathematical significant value. And so we also are trying to pay attention to that too. That I think is critically important for a passive house audience, because as the grid decarbonizes, and as we consider cumulative emissions, which passive house mainly deals with for energy use, we need to think about how passive house itself situates itself in that world. As we are decarbonizing, energy use will become less and less impactful. It's still the primary and most impactful change you can make. But this chart from Rocky Mountain Institute, I think, is a really helpful one to understand that. Why is it becoming cheaper and cheaper and more appropriate to use say renewable energy, right? And the grid decarbonized follows suit. Well, it's far more efficient to use work energy, so kinetic energy and solar energy, solar radiation to do work services than it is to use heat services to do that, right? It's just significantly more efficient. There's less loss. And the world needs more and more work services versus heat services, because we're radically reducing the amount of heat we're using in our buildings. and also the planet is warming at the same time. And so as these bars become equal and the blue bar starts to supersede the red bar, it is going to be financially and literally more efficient to provide that energy from renewable sources that don't have to use combustion. That is going to continue to happen because it makes financial sense for it to happen. So we need to recognize that as passive house designers, because a lot of the formation around passive house was based on an assumption that creating energy was necessarily a negative impact. And it still has negative impacts in overproduction, for sure. That's a separate topic. But the difference in the fossil fuel combustion is starting to change and will continue to. So that gives us our assumptions. I'm going to share with you this project, which is the first project that we were able to kind of apply all of these approaches to a single building. This is the Ecology Atlantic Collins House, which is an passive house level energy performance, all mass timber construction, CLT and glulam, wood fiber insulation throughout from Timber HP and Styco, extremely low refrigerant volume. We were looking at fugitive refrigerant loss in this building as well, again, being holistic. The low mass structure, so there's no bearing walls in this building at all. There's shear walls, but no bearing walls. A owner-controlled renewable energy production on and off-site. So by off-site here, I mean about 3 miles away, so it's in the same general zone. And then minimal and movable reusable furniture. So this was a really exciting project to actually have a client that was willing to entertain the opportunity to try all of these things and kind of let us do that behind the scenes, and was interested in seeing the results of that. And other things as we watch, this building get built as fast as any building ever. The site was also a previously disturbed site. Oh, I said that already, but the ability to kind of like maintain an existing ecosystem was possible in this building as well. Project is in Bar Harbor, Maine, across the street from one of the entrances to AIA National Park by trail and on the Atlantic Ocean. It was also exciting because it's a project that was our second project on this site with the Davis Center for Human Ecology just up the way on campus. The erection of the CLT and mass timber, this is the CLT and glulam structure, happened over the course of 3 weeks, and we're able to also allowed us to significantly reduce the amount of concrete in the building by point loading the system. Again, was an all biogenic insulation solution, in this case wood fiber, both inside and in the stud cavity and outside with the rigid board. And we were paying special attention to make sure almost as many of the systems as possible were surface mounted if we could, that we could try to make this building something that could be deconstructed and didn't have to be demolished. A lot of unfinished surfaces or minimally finished surfaces, that was help. The CLT certainly helps that a lot. And also a lot of kind of like equitable approaches. Is it completely gender neutral, all bird safe glass throughout, as many possibilities as many times as possible. We're trying to expose the CLT. Again, you see the exposed surfaces here. Communal cooking, it's a dorm building, but it actually is on a campus which does not have full meal service the whole week. So the students also need to be able to cook here. So we had trying to do that in a collective way that reduced the impact of that service. And then again, exposed systems to try to reduce the amount of material usage. So you see that here in the hallways, and then lots of shared kind of, let's call it soft sustainable approaches, in like shared common storage, bike storage covered for every occupant on site, et cetera. So just some last views through the building, back across Frenchman's Bay to Bar Harbor proper. And we ran this in our own framework, and we were able to see some results that were exciting. In most categories, we were able to achieve our 80% goal. We learned that on water cycles, a lot of that is so outside of what we can control, especially when we're doing a larger building that's connected to city water, but it was helpful to analyze it and test those assumptions so we know going forward what things we could do to try to change that. And then we assessed it both in an upfront carbon methodology and in a WLCA methodology. So here's how you start to see those differences, right? In upfront carbon, if we only measure to the opening of the building, even with measuring the construction emissions, we're actually getting a negative number from all of that biogenic storage. And it's why RICS doesn't recommend measuring those together, because the reality is this is not a negative carbon building. I would contend that it's not physically possible right now to build a 0 or negative carbon building. But when we go to WLCA, and I include things like full life cycle 1, the deconstruction of the building 2, you can see how big that C category is. And the use of the building, particularly the refrigerant leakage, that we're pushing into something that is definitely positive. So we came out at just under 400 kg CO2 per meter squared. But the reality of that was that that is not, even though they're not equal, this is an important slide for everyone, like traditional LCA, upfront carbon, WLCA, if I run all of them on the building, I get different numbers. To me, when I just think about math, like that's problematic, right? The numbers are different, like something's not working right. And so we try to just focus on the whole LCA. Trying to pay close attention to reuse on this building too. We are able to establish carbon budgets now for buildings. So if we think about our total global emissions budget of 230 gigatons of CO2 to stay below 2 degrees, we can track that all the way down within the US or any country into what a single building should use per square meter to stay under that goal. So if we look at that, we can get to, through some pretty simple math, get to 480 kg CO2 per meter squared. So even though 400 is a lot more than negative, it was still below this target. But it took literally doing all of those things I just described to get there. Like so many things to get to that point. The biggest one still is passive house, right? Just the huge reduction of going from a baseline energy use to passive house is massive. But what we want to learn from that is like the mental model of being open to doing all of that is probably the most important thing than the modeling itself. Like it is possible to do a low carbon building, but it takes kind of focusing on those big categories that we just talked about. And we can make these things differently. So some quick takeaways, and then I'll go to some questions. The first thing we want to ask is, can this be made simpler, right? Simple buildings have a higher propensity to be reused. So when we did this project, we're focusing on a standard grid, but something that could also easily be adopted to other programs because it doesn't have bearing walls. Like this could become a classroom building if it needed to be. It could become an office building if it needed to be. Focusing on negative impacts like passive house energy reduction are still primary, and electrification is non-negotiable. If we don't electrify our buildings, we're looking at buildings that could potentially be irrelevant in a world where we're using work energy for work services. We want to look at biogenic carbon storing materials, but not in isolation, right? We can't just swap the hamburger for the veggie burger. It's not enough. It doesn't actually create a significant reduction on its own. Now, working together, you can solve two problems with biogenic carbon storing materials. You can short-term store and still create point-loaded light systems that have a low emissions impact, but you have to be considering both at the same time. Otherwise, the number doesn't change much. So that's true for both the insulation and for the structure, right? Think about both. We want to pay a lot more attention to systems than we have been. They have a significant impact, not just things like refrigerants, but the systems themselves. That data is really new, but there's enough to make estimates. And for things like refrigerants, there actually are online calculators that I'd recommend people use. So MEP 2040 has an online calculator for refrigerant leakage, and I'd really recommend people use it. We want to consider our ecosystems. They're not emissions specific, but responsible habitat attention can yield sites that are less emissions impactful because they use more resilient plants that need less irrigation or no irrigation, and they save local species. Things like bird safe glass and kind of low intervention landscaping, to me at this point, is also almost a non-negotiable. And I would like to recommend people truly consider the potential for circularity in designs. When you're sitting down to start design, you're starting a process that someone else will have to contend with in the future when we're dead and gone. So how are we designing things that are flexible? To me, I've said a lot of that already, but point loaded, long spans when we can, less bearing walls are some of the primary reasons that buildings get demolished. Program won't fit in building is like the number one researched reason for a building getting demolished. So not all specifications and materials, but that's our kind of 5 key takeaways. I'm ready for questions whenever you guys have them. And I can go to any point in the slide deck too.
Perfect. Thank you so much, Tim. I just want to reiterate that, we dream of a zero carbon building within our lifetime. And, I think that measuring that and starting to have standards for what that looks like is how we get there. So thank you for sharing this and also for sharing so many resources and tools along the way. I think that's going to be really helpful for a lot of people here. So before we get into questions, Kim, do we have more? We want to thank some sponsors.
Awesome. Thank you, Tim and Zoe. Starting off with our founding sponsors, we just want to quickly thank 475 High Performance Building Supply, Ingley Architecture, Partel, Rockwell North America, and Zola Windows. Our champion sponsors, Bowiso, Icon Windows and Doors, Intelligent Membranes, and Source 2050. On to our patron sponsors, Brennan and Brennan, Holzer Arm System, Innotech Windows and Doors, Lamelux, Longboard, RDH Building Science, and Sanderson Design. And our stakeholder partner is NYSERDA. And I'm going to just jump into our events really quickly so we have enough time for, or as much time as possible for the Q&A. Curtis and Ginsberg Architects, they are acting as our accelerator partner of the week.
I'm going to open up with a question because I had one selfishly, and then we'll go to T. Kakandis. I'm not sure if you're on, but you'll be up next. Tim, just a quick question on where you pulled your national averages from your internal framework tool.
So you mean in like the 5 category criteria?
Yeah.
Yeah. So what we did as best we could, because some of those categories, it's hard to develop them, but we use the tools at our disposal. I would suggest for architects working in the US, the AIA's database, particularly through the Framework for Design Excellence in the non-energy categories, has pretty good information at times. The energy categories, we're using updated national EUIs. And so mainly those are to kind of try to set a benchmark though. I think in our internal framework, it's much more about us benchmarking for us so that the future designs can get better. We aren't trying to typically use those numbers outward facing because we've found it's more successful with the clients for them to have an understanding of the concept behind what those things are than actually knowing exactly what the numbers are, because it can be overwhelming and actually usually a turnoff. But generally, we just try to find the best information we can for it from whatever sources we can get them to try to change it over time. I wouldn't call it like a hard benchmark in that way.
Well, thank you. So T, there you are.
T for Tom. Congratulations, Timothy. You're the very first speaker on embodied carbon that I've ever heard even mention refrigerants. So I appreciate that. Can you speak a little bit about what the process was, just a little bit more than the presentation did?
For which, the refrigerants?
Yeah, how you considered mechanical systems and
yeah.
And then accounted for that as part of your. I think my original question was how is CO2 equivalent accounted for, but you addressed that.
Sure. So yeah, so refrigerants are starting to become a hotter button issue. I'd say more so outside of the passive house space and in the kind of just general WLCA practitioner space, which is not a ton of people. It's a small group, but it's something that we've been measuring for a little while now. And I think for practitioners of Passive House, I will just tell you, you have a leg up on everyone else in refrigerant reduction, refrigerant leakage reduction. So when we're talking about refrigerant impacts, we're talking specifically about the leakage of that refrigerant and its equivalent relationship to a kilogram of CO2. That's reported as a ratio. And for the most typical refrigerant used right now in the US, which is R410A, that is a 2,000 to 1 ratio. And so it's a significant impact. And you measure it. It's actually not terribly hard to measure. There is an online tool, as I said, through MEP 2040 that'll do it for you. But you need to know your total refrigerant charge. Thankfully, on every submittal for any refrigerant-based system, it's listed as an item because they have to buy it, right? You have to get the system charged. And so you can just get the volume off of that, and you can use that tool to assess it. It's free, it's online. You can go to MEP 2040 and look at it. As far as taking a passive house approach to it, what I've found is because a lot of these future low emissions refrigerants are not yet available or not yet compatible with consumer systems, particularly at the scale of buildings that most passive house practitioners are working, I tend to recommend people start by taking I think, truly passive house approach and say, can I just reduce the volume of refrigerant? Like if I have to buy less refrigerant, then that leakage is going to have less impact because there's less of it to leak. So for instance, on the building you saw, the way we did that is we used the ERV as an air handler instead of just as an ERV. And instead of having to pipe refrigerant throughout the building to air handlers in the space, which would have increased the amount of volume substantially, we only had to pipe it 5 feet on the roof from the condenser to the ERV. We had to buy a custom coil to do that. We had to make a coil, but it also saves significant money in not having to pipe the building and not having to buy all the interior air handlers. So it was kind of like a win-win for everyone. And it did reduce the volume of refrigerant by 79%. So when we're talking about these like 80% reduction ranges in passive house, that was a coincidence, but it was a design decision that myself and the mechanical engineer made without the client even being involved. So we're like, it's going to cost less, it's going to be way less refrigerant leakage, way less maintenance, and total win. So I'd encourage people, if you're getting into these low loads that passive house already has, you might be able to do the same thing on your project. Like an ERV already pushes air places. It can push air over a coil just as well as it can push air over no coil. And it will still do all of the ventilation recovery that we ask it to. So it's just about thinking creatively about the systems there. So maybe that's too much information. Yeah.
I'm not sure if I'm next, but I'll go ahead. I would be
Yes,
interested in the foundation detail. Is that possible?
So for that project, because of the scale, that is a slab on grade. It's actually a slab on ledge. The slab kind of morphs to the ledge with a small frost wall. That was beneficial because it does significantly reduce the amount of concrete, but that's not appropriate everywhere. We don't, I'm always trying to find ways to limit concrete because it's probably going to be the last of our major materials to decarbonize in the construction space. And so I take the same approaches with refrigerants. If I can do a simpler foundation system that uses less concrete, I try to do that. And then using standard passive house details to thermally break it and decouple it from the ground. So nothing unconventional in that foundation on that project.
Thank you.
All right, Tom is up next. Tom, did you want to unmute or we can ask your question for you?
Tom Phillips, he had a few questions.
It looks like the first one is cool stuff, life cycle assessment. 1, how are you weighting embodied carbon? And 2, what time frames are you using? For example, 60 to 100 years for building shell and much hotter climates.
Yeah, let's see. I don't know if I totally understood the how are you weighting embodied carbon, but maybe he can expand on that. As far as time frame, we use the standard 60-year time frame. That is the current, let's call it accepted duration. And the reason that it's 60 years is based on average length of building. And I'm trying to like educate some of my staff on this too, because they're like, how come like we want to build buildings that are more durable than 60 years? Why do we measure to 60 years? And it's like, well, yes, we do that, but we can't be speculative when we're doing assessment. It's got to relate to the average lifespan of buildings in the space of measuring these things. So the system boundary is the same for any building. So much like we have to accept a standard unit to go by area instead of the gross additive emissions, we need to divide it by area. We want to divide it by a standard duration too. So if we compare it to a building that doesn't have as long a life expectancy, they can at least be assessed together. So that's the second part of the question. I'm not sure about the first one.
All right, we are running out of time for questions, but we'll try to go through them quickly. John Hyde, are you on
Yes.
and want to ask?
Yep,
Great.
thanks. Hey, just kind of expanding on that last question a little bit. So if you're using 60 years, like much like the D, it seems like a lot of that is a projection. Does RICS, or how are you figuring out, like, if it feels like you can project maybe 10 years of the building's use pretty accurately, or 15 maybe, but beyond that, it seems like it's is there any guidance so like people can't game numbers?
Yeah.
And I'm just trying to like
Yeah.
renovate every 6 years or 10 years, or as
Right,
energy's
so-
getting more clean. So.
Yeah, so again, like in order to try to just be quick and get to more questions, these are based on data sets that are derived from EPDs that are now accepted across multiple materials and regions, and they're usually regionally specific, or at least the regions defined. And then the level of specificity in the material selection can be narrow and narrow depending on if it's generic or a specific material. I think that people get into a headspace, and this is just a correction for everyone on the call in case there's a false assumption here, that you're trying to accurately predict your exact building. And in a sense you are, but you're using it based on the mean data for the materials that you're picking right now, right? So like if I select a siding material, it's going to base it on the average amount of times that will have to be replaced over the next 60 years. Because in order to complete the math equation, we need to have a certain set of things as constant and accepted averages. Because I can't, if I put in the siding, I can't know exactly how it will be maintained and if that will yield more replacement or less. What I can know is on average how often that material needs to be replaced in this region. And that's how those material data sets are derived. So you're always using averages, whether you know it or not, and you have to be, because otherwise you're assuming either something that's going to be more impactful than it will be or less, which would be weighted, right? So that's why it does that. That's just common methodological practice across any of these, Upfront, LCA, or WLCA.
Cool, thanks.
All right, I think Jean had a question about a link to the RICS methodology. I don't know if that's a link or that's like a PDF for purchase.
It's free, and I could send the link, but I don't know if I'll be able to do it while I try to answer questions. I'm happy to send it to you after the meeting, or to Kim if she wants to circulate it.
Can you put it in the chat?
I'll try to do it, but I have sometimes a hard time multitasking. I'll do my best.
I mean, you can send it to me after and I'll make sure it gets to who it needs to get to.
Wonderful. I'll do that because that will go better, I think.
Someone found it. I love this community.
Wonderful.
David, thank you for
Thank
being
you so
quicker than
much.
us all.
And yes, it is free download.
Okay, we'll make sure to ping that. And then we might have time to squeeze in Rolf's question, but we're running up on the hour. Rolf, are you around?
Yeah, sure. Thanks. I was just curious about the slide you shared that showed kind of the carbon budget for
sure.
each building, and it works back to the global emissions limit. And I think, was it 2 degrees Fahrenheit or 2 degrees Celsius that was based on?
2 degrees Celsius.
Okay.
It's
And
based
I
on
was
the Paris Accords projections. Yeah.
okay. And I was just curious where that sequence of projections were coming from. Is that from a report somewhere, or?
Yeah, that could be its own whole discussion. I'd be happy to entertain it. If you want to email me, I can talk to you about it. But basically, it was a working group of, I think it was 14 or 15 of us working across the US together to try to see if we could set a target, and using the projected data that was yielding a remaining carbon budget in the Paris Accords, and then just working down each subsequently smaller pot to get to that point, just based on essentially division based on history of emissions. So like, for instance, US contributes pretty consistently about 10 to 11% of the emissions worldwide. So if the assumption is that everything's decarbonizing at this rate to stay under 2 degrees, we would continue to contribute a similar amount as a percentage, but that gross number would get lower every year, right? Obviously, we don't know if that will happen, but we're trying to set targets to assume it could, right? And that's how we got to it. So do that with each individual subsequently smaller subset within that. That's how we derived it. But yeah, that's very brief, and I can show you the spreadsheet that we used to get it if you want to contact me after.
Yeah, I think I'll do that. It's very interesting, important work. It reminds me of the energy budget setting that was done by the original, Wolfgang Feist and so forth.
Yeah. And just so people understand, we did talk that's on that point. We did talk very briefly about the Earth continuing to absorb carbon. This is like being used nefariously in certain like political arguments in parts of the world right now. That is already taken into account in the Paris Accord projections. So if we're doing devaluing for future carbon on our projects, I talked about that a little bit with the AIA report. We need to also take into account that we shouldn't be doing that if we're trying to stay under a target for 2050 based on Paris, because Paris already does that separately. Side point, super nerdy, but just so people understand, that's not a cheat code. You can't use that.
Well, thank you so much, Tim. We have many more questions, I know, and I think we would love to have you back, basically, is what this means, because we know you have a hard stop.
Happy to come back.
You got to dig into all of these other things that you said. Oh, that could be a whole other presentation. So thank you so much. Obviously, this has been really valuable, and thank you so much to everyone for joining.
Thank you all. Thanks for having me. See you soon.